class. Today we're going to be covering 7.6. And in 7.6, the only difference between 7.5 and 7.6 is that now you're going to have a number out in front. So yesterday you would have looked at a problem that might have looked like this. Say x squared, oops, my pencil doesn't want to work here, x squared plus 8x plus 7. And you see how there's no number out front. And so in today's lesson, they're going to put a number out front. But our problems are essentially going to be exactly the same. We're going to be creating our two binomials, and we're going to multiply these together, or we're going to FOIL them out to make sure we get this trinomial back. Okay? So really the big key for today is if you can pull out the greatest common factor. Okay, if there is a greatest common factor, you want to pull that out. Okay, that is probably the biggest piece in today's lesson. And then really the other thing you just have to watch for is these are kind of a puzzle. Today's lesson is going to be a lot of just trying, and I really wish we were together because I would ask you for different suggestions. But since we're not, I'm just going to have to make the best of it. So if you notice here, I have 9 problems, and again, they look really similar to what we did yesterday. The only difference is we have this coefficient out front. Okay, so the first thing I'm going to do with number 1 is I'm going to pull this 2 out. So I'm going to take and divide everybody by 2. So I'm just using this as my greatest common factor. So if I divide by 2, it's like, what am I left with? And then if I take negative 14 divided by 2, and then negative 36 divided by 2, that is what I'm left with. Now, if you notice, this looks just like what we did yesterday in 7.5. So we're just going to carry the coefficient out front down. And then now with our trinomial, we're going to make our 2 binomials here. And we're going to do the same thing. We're going to look at this and say, what makes c squared? So that's going to be c times c. And then we're going to look at the 18 and ask ourselves, what are the multiples of 18 that will combine to get 7? So we know it's not going to be 1 times 18 because it's not going to get us a 7. But what about 9 times 2? Notice if we go 9 minus 2, we get 7. So we're going to put a 9 and a 2. And remember what we learned yesterday. If our last symbol is a subtraction, that means that these have to be alternating. Now, if I were to put the plus right here with the 9 and the minus 2, watch what happens when I check my outers and my inners. This would be a negative 2. And this would be a plus 9. Do you see how I'm not getting the right symbol? So that's how I know to switch it. And then the trick that we learned yesterday too was whatever this is needs to go with the bigger. So then this would be a minus 9 and a plus 2. And so we would have a positive 2 and a minus 9. And notice now that gets me the right middle term. So this is the factored form. So see how it says factor each? That's what they're talking about here. Okay, so let's do one more together and then maybe I'll have you pause it and you can try it on your own. So in number 2, I can see that everything is divisible by 4. So I'm going to go ahead and divide everybody by 4. So if I divide the first one by 4, the second one by 4, and actually I'm going to use my calculator on this, 140 divided by 4 is 35. So I didn't know that when I used my calculator. Now that I have it down to this stage with the coefficient of 1, I'm just going to pull the 4 out and put my 2 binomials. And then I'm going to ask myself what multiplies to get a squared. So a times a. What's going to multiply to get 35 that will combine to become a 2. So again, I know it's probably not going to be 1 times 35 because that doesn't get me to a 2. But I'm thinking of 5 and 7. So hopefully you were kind of thinking that in your head as I was pausing. I'm going to go ahead and put the 5 and the 7. And notice this tells me that my signs are going to alternate. So this one is going to go with the bigger. So I'm going to put the plus 7 and the minus 5. And I'm going to go ahead and check my outers and my inners one more time. So that's a 7a, and that's a negative 5a. That becomes 2a, which is what I wanted. So this is the correct answer, okay? So if you could pause it here, if you can see it on the projection or on the thing, I want you to try numbers 3 and 4. These are both subtractions, and then these are both addition symbols. Those are additions. We don't have any divisions in this. Also, we did post the hard copy of the notes online as well, so if you want to bring up the hard copy, you could. But why don't you try numbers 3 and 4 to pause the video and try them on your own. All right, hopefully you tried it. So let me just quick go through it. I'm going to pull the 3 out. So I'm just dividing everybody by 3. And so there's my trinomial. And then I copy the 3 down and I do my 2 binomials. And I'm going to go with x times x. And now with 8, I don't think I'm going to use 1 and 8, but how about 4 times 2? And this tells me my signs alternate. So this one gets the bigger. So I get -4 and a +2. And if I quick check my outers, that's a +2 and a -4. Yep, that's the right middle term, so I know I've done it correct. Now, as I said in yesterday's video as well, the order of these, the parenthesis order does not matter. So if you put x + 2 and x - 4, that would be fine, and then we would just keep the 3 out front. So it does not matter which parenthesis comes first. That's kind of just, I guess, whatever pops into your head first. Okay, so then this number 4 that I asked you to do, if we pull out the greatest common factor, would be a 5. And then we have s² + 11s + 10. Notice we've got it down to our trinomial with a coefficient of 1. And we're going to do our 2 binomials. We're going to go s times s. And now what multiplies to get 10, that will combine to get 11. And so that must be 10 and 1 this time. We haven't really seen that combination very often, but 10 + 1 gets 11. And if we notice that this symbol is a plus, so that means they're both going to be addition. And if we quick check, that's a 1s and a 10. 1 + 10, we know we've done it right. Now, before we move on to the next one, I do want to just show you quickly in this particular problem that I could have not factored out the 5. So if I would have kept the 5 in and I would have tried to do my 2 binomials like this, that would be quite a bit more difficult, because how do you get 5s? You would have to go 5s, 1s. Or do you go 1s, 5s? And then what are you going to do with the 50? Because now it's going to get multiplied by the 5. So what are you going to use now? Are you going to use 2 and 25? Are you going to use 5 and 10? Like, what would you use here? And so if you don't pull out the greatest common factor, it just really, really makes the problem so much harder, okay? But now when we look at number 5, if you notice number 5, this middle term is not divisible by 2. So we cannot pull out a greatest common factor on number 5. So we really just have to leave this 2 out front, and that's going to complicate things. But do you see this negative sign? We can get rid of this negative sign as our greatest common factor, and I highly recommend doing that. You're going to see down here below that there is no negative out front and there is no greatest common factor. So we'll talk about that in a minute. But let's pull this negative out. So we're going to pull the negative out as if it was a greatest common factor, and we're going to be left with our trinomial. So we're pulling the negative out. We're pulling this negative out so it flips your sign. And then we're pulling a negative. So it's kind of like a positive divided by a negative. And so notice what it did was it flipped all my symbols. Now from here, I've got my 2 binomials, but I'm going to switch to a pencil because we might have some trial and error here. 2 is a prime number. So I know my only options are 1 times 2. It's just, do you want the 1 to come first and the 2 to come second, or vice versa? So I'm just going to put those down for now, and I know this is d times d. But now look at that 6. I have 2 different combinations to multiply to get 6. I have 1 times 6, and I have 2 times 3. But here is the issue. Notice how my parentheses are. I'm just going to recopy this on another sheet. Let's say we go with the combination of 2 and 3, okay? What if I put the 2 here and the 3 here? This is going to give me a 3D, and this is going to give me a 4D. Now, my symbols have to alternate, so if I were to go like this, I would get a negative 1D. But do you see how, in a way, I just got kind of lucky? I got kind of lucky by putting them there. What if I would have switched them? Let's just say I would have switched them. So I did get kind of lucky on this. Let's say I would have put the 3 first and the 2 here. Watch as I do the outer, 2D, inner, 6D. That's not going to give me the right answer. So these would be incorrect. So I definitely recommend that you use a pencil for this one because there might be some trial and error. So let's put the 2 here and the 3 here, and we already know that we checked the outer and we checked the inner, and then we want this to be a positive D. So see how I have the wrong one here? I was probably looking at the original. I want this to be a positive. So I want the 4 to be positive and the 3 to be negative. So I need the 3 negative, the 4 positive. So 3 negative, 4 positive. Now let's just quick check that again. So first, 2D squared, outer, negative 3, inner, 4D, and last, negative 6. Now notice that does give me the right symbol. So this is my answer. Again, when you have a coefficient out front, it is a little bit of a puzzle. You're going to have to just kind of use some trial and error, and I highly, highly recommend pencil. So notice I switched to a pencil here. It's just sometimes the pencil is a little harder to see on the projection. All right, first, no greatest common factor. Man, if that would have been even, we could have at least got a 2 out of there. But the only thing we can do is pull this negative out. So let's pull out the negative. And we're going to divide everybody by a negative. So we get a positive, a negative 14, and a positive 5. So if you were to redistribute the distributive property here, notice you would get the original back, okay? So now I'm going to put my 2 binomials down, and I'm switching to a pencil. 8. Again, I wish I was there with you. What do you want to use for 8? 1 times 8? Or 4 times 2. How about we go with 4 times 2? Again, nobody's here with me. I'm by myself right now, so kind of talking to myself. All right, we might have to switch that. I don't know. 5. Well, 5 is a prime number. There's only one option. It's 5 and 1. It's just where does the 5 go and where does the 1 go? Does the 5 go here or does the 5 go here? So let's put the 5 here and the 1 here. And let's not really, I guess, worry too much about our symbols right now. We can do those in a minute. But let's check this. 4 times 5 would be 20, and 1 times 2 would be 2x. No matter what I do, either if I add or I subtract, I'm not going to get to a 14. So I know this is not right. So I can either switch the 4 and the 2 to become an 8 and a 1, or I could switch the position of the 5 and the 5 and the 1. So let's switch the 5 with the 1. Now let's try this. 4x, middle, 10x. Ooh, if I could get those to add together, 4 and 10, I get my 14. So let's look at our symbols. This tells me they're going to be the same. And when I look back, they're both subtractions. So look at that. A minus 4 and a minus 10. That's a minus 14. And then if you notice, a negative times a negative is a positive. So now I know I've done this right. So a negative symbol can also be considered a greatest common factor, even though we may not think of it that way. It actually does hold the same properties. Okay. All right, let's give number 7 a try. Now, number 7 is going to be a challenging one because there's not a greatest common factor. And notice how many different options we have for 12 and for 28. But we just have to give it a try. So let's go ahead and put our 2 binomials down. And again, I really wish I was there, we were together so I could ask you guys for some input. 12. So the combinations that multiply to get 12 would be 1 and 12, 2 and 6, and 3 and 4. So how about we just try a combination? I kind of don't think it's going to be 1 and 12 because 12 times anything gets pretty big. So let's just try 2 and 6. So we're going to try 2G, we're going to try 6G. And then the nice thing on this problem, my eyes kind of caught it, is this is a plus sign. So if this is a plus, we know that we look back and both of our symbols are going to be subtractions. So that really helps us. We can fill those in, and I'm kind of putting those in a little darker because I know those are not going to change. It's when your last sign is a subtraction where they alternate that can be a little bit more difficult. Okay, 28. I'm going to say 1 and 28, 7 and 4, and 2 and 14. So I'm kind of trying to maybe stay away from this 28 and this 14 because I feel like that might get kind of big. So I'm going to try with this 7 and 4. So let's just give it a try. Let's try 7 and let's try 4. Okay. Now what we've got to do here is we got to check our outers and our inners to see if we can come up with this negative 37. So this will be a negative 8 and this will be a negative 42. Well, I can already tell that's too big. So how about let's switch the 7 and the 4. Let's put the 7 here and the 4 here. And notice how I'm using a pencil. You really need a pencil in this lesson. So if we multiply those together, that's going to be a negative 14. And then on the inner will be a negative 24. And so if we add those together, that's a negative 38. Oh, we are so close. But we're not 37. So I really like the 4 and 7. And honestly, class, I don't have the answer key in front of me. So let's switch the 2 and 6. I really don't want to switch this 4 and 7 because I think these are going to be even bigger. So let's switch, instead of using the 2 and the 6, let's go with the 3 and 4. So let's put the 3 in the 4 and let's give this a try. All right, that's going to be a negative 21G. And then inner will be a negative 16G. Oh, look at that, negative 37. So I've got it. But do you see how that took me, 3 different tries? Class, this lesson is a little bit of a puzzle. You may not hit on the right combination your first try. Because you have a coefficient out front, you can't just say what multiplies to get 27 that makes up 8 because or 37. None of these do. So because you have a coefficient out front, it's going to be a little bit more challenging. So why don't you pause the video here and try numbers 8 and 9. And again, we did upload this online so you can see the symbols a little better, but I'll quick read it. This is a 6k squared minus 11k plus 4. And this is a 9w squared plus 9w plus 2. Remember, these are plus symbols. We don't have divisions. So why don't you pause it here and quick give it a try? All right. Hopefully you paused it and tried it on your own. So for 6, I'm thinking to go with 2k and 3k. And then 4, your either options are going to be 1 and 4 or 2 and 2. And many of you might have tried 2 and 2 first, but you would have found that that didn't work. But I'll go ahead and show it to you anyways. Notice the plus sign, so that tells us they're both going to be subtractions. So if we test our outer, that's a minus 4k, and our inner is a minus 6k. That's 10. We need 11. So let's switch this. And let's put the 4 here with the 1 here. So if we add those or multiply that out, the outer, that would be a negative 8k, and the inner would be a negative 3k, which is the 11. And so there is our correct combination. You should always know if you have the right answer if you check your outers and your inners. All right, number 9. So what do you want to use for 9? Chances are it's probably not 9 because 9 times, say, 2 or anything is going to get a little too big. So how about let's go with 3w and 3w. Now, a couple nice things is this is prime. And it really doesn't matter where you put it since these numbers are both the same. So we'll just put a 1 and a 2. This is going to tell us our symbols are the same. So we look back, they're both plus signs. And so we quick check. How about 3 times 2 and 3 times 1? And that's a 9. So we know we have it correct. All right. So hopefully you're kind of getting the hang of it. I just have a couple more problems I just wanted to touch base on. And we noticed they're very, very similar. The only thing that's different is they have that equal sign there. So I don't want to make this video too long. So why don't I maybe just, maybe I'll just do one of them here. But basically what you have to do is whenever it says solve, you have to go one step further. So we are still going to need to get our parentheses, but then we're going to go one step beyond that. So we're going to move the 9 over to the other side. So now it's going to become a -9. And then we're still going to go ahead and factor. And if I could, I would pull out the greatest common factor, but there is not one. So I'm just going to put my parentheses down. 5 is prime, so I don't have a lot of choices. It's just going to be a 5t and a 1t. And you don't necessarily have to write the 1. It's just, it's kind of helpful, but you don't have to do it. And then the 9. I'm definitely thinking you're not going to put the 9 right here because 5 times 9 is 45. That's way too big. And if I put the 9 right here, when I add those together, I don't get 12. So I'm definitely thinking of going with 3 times 3. This tells me my signs are going to alternate. So let's quick check the outer. That would be a 15. And the inner would be a 3t. Notice I want this to be a plus 12. So I would want 15 minus 3. So I want the plus to be with the 15 and the minus to be with the 3. And now notice I know I have this factored right. So I have the right middle term. But because it asks me to solve up here in the directions and because I see the equal sign, that means I have to go one step further. So I have to set each of these equal to 0. And then I set this one equal to 0, and then I need to solve it. So I'm going to move the 3 to the other side. I'm going to divide off the 5. And right now, I wouldn't worry about fractions or decimals, just kind of leave it. And then on this one, you're going to move the 3 over, and so these are your 2 solutions, okay? So 11 and 12, if you want to go ahead and give these a try, I can write down the answer for you as well. If you want to know the answers to number 11 and 12, I would have first moved the 2 over. So I would have gotten a -2 is equal to 0. And then you would want to try to come up with your combination. Now, I will tell you that this combination might take you a couple tries, but I already have it worked out. It's 4a minus 1 and 3a plus 2. And if you check my outer, that's an 8 minus 3, so it does work. And then you would set each one of these equal to 0, and then you would solve it. So you would move the 1 over to the other side, and then I would divide off the 4. And so there's one answer. I would move the 2 over to the other side, and then I would divide off the 3. And then there's my other answer. Notice they're both fractions, okay? Now I'm at the edge of my paper here for number 12, so let me go down below here. So number 12 looked like this. Okay, that was what the setup for number 12 looked like. If you move the 8 over, that's what you would get. Now again, this may take you a few tries trying to come up with the combination because 15 has a couple options and 8 has a couple options, but it works out to be 5b minus 2 and 3b plus 4. And if you check my outer, that's a 20, but that's a -6. So 20 minus 6 does give me the right. And then I would go ahead and set each one equal to 0. And I would solve them individually. So now I'm going to divide off the 5. And so there's one answer, 2/5. And then I'm going to set the other one equal to 0. I'm going to move the 4 over. And then I'm going to divide by 3. And remember, we will talk about what do these solutions actually really mean, or, why is there 2 instead of 1? So we'll talk about that in the next chapter. But right now, just really, really focus on getting this right combination and then setting each piece equal to 0 and solving. Now, I did want to mention one other quick piece that was not on this page, and I kind of wish it was, but that's okay. Do you see a problem like number 3? If this asked you to solve, so remember how if it has the equal sign behind it like that with a 0, if this asks you to solve and you now have factored it down to this and you have an equal 0, some people wonder about this part. And honestly, you just set them equal to 0. But do you see how there is no variable? So you don't have to worry about it. That would not be a solution. Then this part right here, you would set equal to 0. And then this part, you would set equal to 0 as well. Okay? The only time we have to worry about this is if there's a letter behind it. So if it would have looked like this. So do you see how I put an X or a variable behind it? Now, this would be a solution, and a solution. So you would just go 3x is equal to 0. You would divide by 3, and you get x to be 0. Remember, 0 on top is not a bad thing. But in this particular lesson, do you notice how none of our problems today had a variable out front? They were just whole numbers. So these would not actually affect your answer. So your answer would be a +5 and a -7 if you were asked to solve. So just really watch if you have the equal sign or if there's not an equal sign. Now, please take your time and don't be discouraged, and please use a pencil. This lesson can be a little bit difficult, and it really just got to keep trying those combinations, okay? So please let us know if you have any questions.